Show that y plus 1 all squared multiplied by 2y plus 1 squared take away 1 is 2y to the 4 plus 8y cubed plus 11y squared plus 6y plus 1. So that's just an expanding job. So we have y plus 1 squared, and then in a bracket we've got twice y plus 1 squared take away 1. So expanding the first bracket there gives us y squared plus 2y plus 1. And then if we move to the second bracket, we've got twice y squared plus 2y plus 1 take away 1. So that's y squared plus 2y plus 1. And then when we multiply all this out and tidy up, we get 2y squared plus 4y plus 1. So, multiplying y squared by everything in the second bracket gives us 2y to the 4 plus 4y cubed plus y squared. And then doing 2y times everything in the other bracket gives us 4y cubed plus 8y squared plus 2y. And then multiplying 1 by everything in the other bracket gives us 2y squared plus 4y plus 1. And then tidying that all up gives us 2y to the 4 plus 8y cubed plus 11y squared plus 6y plus 1 as required. Second part of the question is, use mathematical induction to prove that the sum from r equals 1 to n of 2r minus 1 cubed is n squared 2n squared minus 1. So, let's look at the n equals 1 situation. The left-hand side would be the sum from 1 to 1, just one term, of 2r minus 1 cubed, and that's just going to be 2 take away 1 cubed, which is 1. The right-hand side is going to be 1 squared, 2 times 1 squared take away 1, which is 1 times 1, which is 1. So we have the first part done. It is true for n equals 1. We now have the inductive step, where we are going to assume, for some value k, that the sum from r equals 1 to k of 2r take away 1 cubed is equal to k squared 2k squared take away 1. We're then going to look at the next case, which is the sum from r equals 1 to k plus 1 of 2r minus 1 cubed. So, what do we get there? Well, what we've done on this side is just add an extra term, and so we have to add that same extra term onto the other side. So that's k squared 2k squared take away 1, and that extra term with r equal to k plus 1 is going to be 2k plus 1 take away 1 cubed. And so what we have there is k squared, 2k squared take 1, plus 2k plus 1 cubed. Now, at this point, it's worth looking for the target expression. So the target expression is going to be this, with k replaced by k plus 1. So what we're after is k plus 1 squared twice k plus 1 squared take away 1. So, expanding out what we have down here, we get 2k to the 4, take away k squared. And then expanding this bracket using the binomial expansion, we're going to get 8k cubed plus 12k squared plus 6k plus 1. And tidying that up gives us 2k to the 4 plus 8k cubed plus 11k squared plus 6k plus 1, which should look familiar from the first part of the question. So we know that we can factorize it like that. And if we do that, what do we get? K plus 1 squared twice k plus 1 squared take away 1. That's from part A of the question. And that is our target expression. So we are done. All we need is a closing statement.